Let's work through an example using a higher order function. I'm going to type in some code and you can try to figure out what it will do. I'm going to define a function called repeat, which takes in f and x. And while it's the case that f of x does not equal x, that's does not equal, I'll rebind x to be the return value of calling f on x. When that while statement completes execution, I'll return x. Now we're using f as a function, so we need some function to pass into repeat. I'll define g of y to be a function that adds 5 to y and then divides by 3, where division by 3 in this case is using floor division, which throws away any remainder. I'll save that file and load it into Python, and now I'll repeat g on 5. Now is a good time to pause and think about what's going to happen. Work through it yourself, because I'm going to move on in 3, 2, 1. The answer is 2, and looking at an environment diagram will help us understand why. So I've put the same code into Python Tutor, but I'll bind the result to a name called result so we can see it at the end. I'm going to execute the code without displaying exited functions. The idea here is that when we don't need a frame anymore, the Python Tutor will remove it from the screen so that we don't have to keep looking at it. Okay, we begin by executing the def statement, which happens all in one step. And all it does is create a new function with the name repeat bound to that function. Next, we execute the def statement for g. And finally, we're going to evaluate this call expression, repeat g5. G is currently bound to this function, 5 is the number 5, and so those are the two arguments that we pass into repeat. So now we have a frame for repeat, where the formal parameters, f and x, here they are bound to the arguments that we passed in, which are this g function and the number 5. Now we execute the body of repeat. The first thing we do is evaluate the expression in the header of the while statement to figure out whether it's a true value or a false value. Now, as you can see in this expression here, there is a call expression within it, f of x. So we're going to have to call f on x. Now, what's f? It's right here. So we call f on x, and that means we introduce a new frame. Now notice that we didn't call the frame f, but g, and that's because it was the g function that actually got called. It just happens to be that in the previous environment, we had a different name for that function. We called it f in this case, but originally it was called g. So now we're making a call to this g function right here, whose formal parameter is y. We've passed in an argument value. That was whatever x was when we called it here. So now we've passed in 5, and we compute 5 plus 5 is 10 divided by 3 is 3, with 1 remaining, but we throw away the remainder. That's what this double slash means. Okay, so now we have a return value of 3, which means this expression is 3, which is not equal to x is 5, which means that we continue, because this is a true value. 3 does not equal 5. We're going to execute the body of the while statement, which means calling f of x again and binding its return value to x. Now x is currently 5. We pass that in to the g function. We get back 3 just like we did before, and that's bound to x. So now we return to step 1. Evaluate the header expression in the while statement. But this time something's changed, of course. We still have f bound to what it was before, but the name x is now bound to 3 instead of 5. So when we evaluate f of x, we'll be calling f on a different argument. This time it's 3. 3 plus 5 is 8 divided by 3 is 2. So f of x is going to evaluate to 2. X will evaluate to 3. And so those two things are not equal, and we will execute the suite of the while statement one more time. Now we're going to call f on 3, get 2, and we'll rebind x to be 2 instead of 3, which is now done. And we return to step 1. Finally, we call f of x, where x is now 2, introducing a frame for the g function with its formal parameter y bound to the number 2. 2 plus 5 is 7, divided by 3 is 2. So I got the same value out as I put in, which means that this whole expression right here will now be false, because 2 does equal 2. So it's not the case that 2 doesn't equal 2, which means we're finished executing the while statement. We can move on to return x, and x is bound to 2. And that's the result of our computation.